All right, so this is playlist 9. This is the last playlist talking about chapter 10. This is going over section 10.5 on Fourier series. Before I jump into all of that, a few announcements. The exam, as I've said, is going to be next week. I will send it out, or I will post it on Wednesday, probably Wednesday afternoon, and you have sometime between then and the next Wednesday, you should pick a time slot when you want to take the exam. It is open book, it is open notes. You should not talk to anybody else about it, however. I'm really thinking of it more as an elaborate homework, rather than it being sort of computation focused. It's going to be more about ideas. So really, to get ready for that, we're going to have a review day on Wednesday. So you hopefully will be discussing this material on Monday, and the next sort of set of videos, or rather than new material, it's going to be review over all of chapter 9 and chapter 10 that we've gone over, to get ready for the exam, which I really don't want people to be stressed about it. It's not intended to necessarily be that challenging. It's more just encouraging you to talk or to think about these concepts a little bit more. Okay, so that's the exam. You have written homework due on Wednesday. You occasionally have web work when I actually assign it. Yeah, so other than that, there aren't any necessarily announcements I have. So this is section 10.5 on Fourier series. This is like my favorite topic in this class, like just hands down, because it does so many different things. So we're going to talk about what all this stuff, what all this Fourier stuff is. Basically, rather than using polynomials rather than adding up polynomials to get a function like we do with Taylor series, with Fourier series, we're adding up trig functions. And this is going to let us either build up towards a particular function or take a function and decompose it into differing sine and cosine functions. And this actually has a lot of applications in things like physics, when we're talking about electronics and oscillations. It really ties into music. This is what notes or what tone is all about. If you have some note playing, what's happening is that it's oscillating. The air pressure around your ear is going up and down at some frequency, and that frequency is what you hear. So when you hear some sort of music, can you tell that I'm not a musician? But it's going to typically be a combination of different frequencies, and Fourier series is actually going to give us a way of taking what like a microphone picks up and figuring out what all the components are, what all the different frequencies or different notes that are being played, which I just think is really cool. Okay, so the first two videos are videos that I made. They're talking about sort of a lot of the math behind it. The third video is another 3 blue 1 brown video. It takes a very different route and it uses some complex numbers. So I would say that the contents that I expect everyone to watch are my 2 videos following this, and the first 2.5 minutes of that video, because they talk about some sort of music note stuff, which I think is cool. If you're interested, you can continue watching the rest of that video. Again, they take a totally different approach, but I think all of the 3 blue 1 brown stuff is just brilliant. So I certainly encourage take a look at that. If you're confused about the complex numbers, don't worry about it, just skip it. And then the last video that I'm included on here is sort of the B-roll footage from that 3 blue 1 brown video. When I'm talking about the Fourier series and the stuff that I'm talking about, I'm just talking about some function. You give it an x and it spits out some f of x. Another way of looking at it is you could give it an x, as in like an x, so you give it some variable and it spits out both an x position and a y position. In other words, if we're tracing some path in the plane, like our parametric form, if we're tracing some path in the plane, we can think about that as a function as well that can also be decomposed into sines and cosines. So what the last video is is a bunch of different oscillating vectors. So vectors that are going around in a circle, and the control is how big each of the circles are. Each vector is going to be going at a set speed, so either 1 per second or 2 per second, etc. And what I think the really cool thing is that you can use, just by controlling how big all of the different circles are, or how big all of the different vectors are, you can trace out any shape or draw anything. And so the last video is some really great animation of just assorted drawings using these varying length vectors, and the only control you have over what you draw is how big the first or the second or the third vectors are, and everything else is set. Anyway, so take a look at that as well. I think it's really beautiful. Great. All right, I will see you in class.